Let's go over these so you can compare with your answers. So number one, if I mix equal amounts of 50C and 10C water, what will the resulting water temperature be and why? All right, so that's the do now. We're going to answer it again. We just learned about conservation of energy. Energy cannot be created or destroyed, but it can be transferred through conduction. So if they're mixing together, they're able to touch and collide with each other. So we would expect them to transfer energy from hot to cold, and that any energy lost by the high temperature would be gained by the low temperature. Since they're equal amounts and it's the same substance, that means whatever their final temperature should be an average of the two, which would be 30. 50 plus 10 divided by 2. Okay, so now we can explain that. We can say, according to the law of conservation of energy, any energy lost by one substance must be gained by another. This means that as the hot substance loses, the hot water, we can be more specific, loses energy, that energy will go into the cool water. Therefore, the final energy would be a mixture of the two, and so we would expect a final temperature around 30 degrees C. Oh, no, that's a different shortcut than in Word. Okay, I tried to do a keyboard shortcut for superscript and it did not work. All right. Yeah. Number two, using the reading in the figure above, explain where and how the hamburger obtains energy needed to cook. So the hamburger is right here. We can see in this figure that the grill particles, the black, are colliding with the patty particles, and then after, the patty particles are moving. So that means they've transferred energy through collisions, which is essentially conduction. But where did those grill particles get energy from? Well, if we look here, the grill particles got energy from combustion gas particles from this burning methane. Okay, so essentially the energy is coming from the burning methane, which is the potential energy of the chemical bonds, transferring through the grill surface into the hamburger through molecular collisions, transferring that kinetic energy. So we can say the energy ultimately comes from the chemical reaction of burning methane, and say potential energy is turned into kinetic energy during the reaction, and the combustion gases therefore move very quickly. These gas particles collide with the atoms in the grill, transferring kinetic energy. Typo. These grill atoms, in turn, collide with the hamburger patty molecules, transferring kinetic energy and therefore heat, cooking the patty. Okay. We could go in more detail. That transferring heat is actually initiating another chemical reaction where the proteins are denaturing and it's killing bacteria and making it safe to eat and whatnot. But for this purpose of this standard, what we've got on here is enough. If you have questions, drop by office hours.